Today we're going to go over solving exponential equations and logarithm equations. And there are 6 types of equations. Equations that may contain e to the x, or 10 to the x, or any a to the power x. And also equations that may contain ln x, or log x, or log in any base of x, or any combination of these. So 6 types. Okay. We need to remember that the inverse of e to the x is ln x. The inverse of 10 to the x is log x. The inverse of a to the x is log x in base a. So whichever equation you have, what you do is you apply the inverse to cancel it. For example, if you have an equation with e to the x in it, you apply ln x. If you have an equation with ln x, you apply e to the x. If you have an equation with 10 to the x, you take logarithms of both sides. If you have an equation with logarithms, you apply 10 to the x, so you raise each side to the power 10. If you have an equation with a to the x, you take log of both sides in base a, so it will cancel the a. If you have an equation with a log, you raise each side, a to the power each side, to cancel the logarithm. And this is very important to remember when you're solving these equations. So we're going to do a few examples. Okay. The first example we're going to do is this one. Solve e to the power 3x equals e to the power x minus 8. I'm going to rewrite it here. Okay. This is an exponential equation with e. How do you get rid of e? Take ln's of both sides. Because ln is the inverse of e. So what happens to this ln and e? They'll cancel. And this ln and e, they will cancel. So that leaves you with 3x equals x minus 8. This is a linear algebraic equation. Subtract x from both sides. That gives you 2x equals negative 8. Divide by 2 and x equals minus 4. And that's it. Then you're done. That's all you do. So we had exponentials. We applied logarithms. Canceled them. We're able to solve. Example 202. We have log in base 4 of 3x minus 2 equals 2. Here we have a log in base a. So what we do log base a, its inverse is a to the power. So a is 4. So we raise 4 to the power left side, 4 to the power right side. So 4 to the power left side, 4 to the power right side. And I'll put an equal between them. Okay. 4 log 4 will cancel. That leaves you with 3x minus 2. 4 squared is 16. So 3x minus 2 equals 16 is an algebraic equation, linear equation. Add 2 to both sides. So plus 2. That gives you 3x on this side. 2 is cancelled. 16 plus 2 is 18. Divide both sides by 3. And that gives you x equals 6. Okay. Whenever you have a log equation, make sure that the solution is in the domain. Why is there a domain? Okay, yes, there is. Because we have a log. This cannot be negative. This has to be positive. There's 2 ways to do it. You could either say 3x minus 2 has to be greater than 0. And then solve for x. So x should be greater than or equal to 2/3. This is greater than 2/3, so it's okay. Or, once you get the solution, put it back in there. 3 times 6 minus 2 is a positive number. So that's okay. Two or 3. We're solving 4 to the power x minus 9 equals 16. This is an exponential equation, so we need to take log in base 4 of both sides. Okay. Log base 4, 4 to the power will cancel. So that leaves you with only x minus 9 equals log in base 4 of 16. So x minus 9 equals log 16 in base 4, which is ln 16 over ln 4. That's one way to do it. The other way to do it is to take ln's of both sides, and we'll go over that in a minute. Okay, ln 16 is equal to ln 4 squared over ln 4. ln 4 squared is 2 ln 4 over ln 4. ln 4 cancels, so that leaves us with 2. So x minus 9 equals 2, which means x equals 11. Okay, and that works. If you do it this way, you're done. But you could also say, instead of taking log in base 4, if you're not sure which log to take, I'll rewrite the equation again. So just take ln of both sides. Okay, this can be simplified. You take x minus 9 in front, so it'll be x minus 9 ln 4 equals ln of 16, which is ln of 4 squared. And here's the step. X minus 9 ln 4 equals ln of 4 squared. ln of 4 squared is 2 ln of 4. Okay. ln of 4 cancels, so that leaves you with x minus 9 equals 2, x equals 11. So you have two options. You can either do log of 4, and if you're not sure, you can always do ln, and ln will work every time. So the answer is 11. This was not a log equation, so we have no issues of domain. In this example, we have log of 2x plus 3 base 5 equals 1. So I rewrote it here. We have log 5, so we're going to raise 5 to the power each side. 5 to the power left side equals 5 to the power right side. 5 log 5 will cancel. That leaves you with 2x plus 3. 5 to the power 1 is 5. Linear equation, subtract 3 from both sides. So 2x equals 2, x equals 1. This is a log, so we need to check it. If you put 1 in there, 2 times 1 plus 3 is a positive number, so it's okay. So x equals 1 is okay. Next example, log of 2x minus 4 equals 3. There is no base here, so that means it's base 10. Okay, I'll rewrite it here. If it's base 10, it means you raise each of these 10 to the power left side equals 10 to the power right side. These two cancel, so that leaves you with 2x minus 4 equals 10 cubed, which is 1000. Add 4 to both sides. So 2x equals 1004, x equals 502. If you put 502 back there, times 2 minus 4, that's a positive number, so it's okay. Next example, log in base 6 of 3x minus 1 equals 2. I'll rewrite it here. This is log in base 6, so 6 to the power left side equals 6 to the power right side. 6 log 6 will cancel. That leaves you with 3x minus 1. 6 squared is 36. Okay. Linear equation, add 1. So 3x equals 36 plus 1, which is 37. So x equals 37 over 3. It's okay. The answer does not have to be a whole number. It's a fraction. If you put 37 over 3 here, it will give you a positive number inside these parentheses. So it's okay. There is no issue of domain for this one. So make sure you always check to make sure when you start with logarithm equations. ln of 2 plus x equals 0. I'll rewrite it here. The inverse of ln is e to the power. So e to the power left side equals e to the power right side. E to the power ln will cancel. It leaves you with 2 plus x. E to the power 0 is 1. 2 plus x is 1 is a linear equation. Subtract 2 from both sides. And that leaves you with x equals negative 1. And yes, we need to check. If you put negative 1 there, it's ln of 2 minus 1. That's a positive number. Equals 0. It's positive. 2 minus 1 is 1. ln of 1 equals 0, which is true. So not only is it positive, it's also correct.